Welcome back everyone, and what we're going to be looking at today is how to find the general term for a quadratic pattern. So we're starting to wrap up our studies of quadratic algebra, and now we need to look at how to find the nth term of a quadratic pattern. Now remember, a quadratic pattern is formed when the second difference is constant, okay? Or when the second difference in a pattern is the same. So for example, if I was to look at this one here, I could see it goes from 3 to 10 to 21 to 36, okay? Which we're going to look at how to find the second difference now. Our steps that we're going to use here to find our general formula, which we need to remember, that Tn is equal to an squared plus bn plus c, are written here, and we're going to follow those now through example 1, okay? So now let's have a look here. In example 1 here, it says, find the nth term of the sequence 3, 10, 21, 36. So to start off here, I'm going to start with step 1, which is to find the second difference. Okay, so when I look here, I have 3, 10, 21, 36. So I can see the first time here it goes up by plus 7, then it goes up by plus 11, then it goes up by plus 15. Okay, which means we can see here it's not a linear pattern because the first difference is not the same. So now we're going to find the second difference. So between 7 and 11 and 11 and 15, it's going up by plus 4 each time, which means my second difference here is actually plus 4. And now we can use the second difference and the fact that it's a quadratic to find our value of a, the coefficient of n squared. So we know that our rule is a is equal to the second difference divided by 2. So in this case, we're going to have 4 divided by 2, so a is going to be 2. So now I can say, therefore, Tn is equal to, instead of a in our formula, I'm going to put in 2, n squared plus bn plus c. And now I'm going to move on to step 2. So step 2 here is where we're going to use the first term to help us find an expression. Okay, so we're going to use Tn is equal to 2n squared plus bn plus c, and we're going to look at term 1. In term 1, we know that n is equal to 1. So we have 2 by 1 squared plus b by 1 plus c, and we're going to let it equal to our first term in the sequence, which is 3. So 1 squared is 1 times 2 is 2. So we have 2 plus b plus c is equal to 3. I'm now going to bring my 2 over, which is going to make him a minus. So when I bring him over, we get 3 minus 2, so I have b plus c is equal to 1. And now I'm going to do step 3. And step 3 is where I'm going to do the exact same thing, but this time I'm going to let Tn equal to T2. Tn equals to T2. So again, I have Tn is equal to 2n squared plus bn plus c. I'm going to use term 2, so instead of n, I'm going to sub in 2. So I have 2 by 2 squared plus b by 2 plus c is equal to my second term, which I can see is 10. Okay, so 2 squared I know is 4 times 2 is 8. 2 by b is 2b plus c is equal to 10. Again, I'm going to bring my 8 over, which means he's going to become a minus. So I have 10 minus 8, which gives me 2. So I have 2b plus c is equal to 2. So now I'm going to take my two equations. B plus c is equal to 1 and 2b plus c is equal to 2. And I'm going to put them together for step 4, which is my simultaneous equations. Okay? So I'm just going to move over here so we have enough room. So step 4 now is to find my simultaneous equations. So we have b plus c is equal to 1. We have 2b plus c is equal to 2. So I can see the easiest ones to get rid of would be the c's. So I'm going to multiply the top line here by minus 1. Okay? So when I multiply the top line here by minus 1, I get minus b minus c is equal to minus 1. 2b plus c is equal to 2. So again here I can see my c's are going to cancel. I'm going to add the other variables together, which means I get 2b minus b just gives me b. 2 minus 1 just gives me 1. So now I'm going to use the top equation, b plus c is equal to 1, to help me find c. Instead of b, I'm going to sub in the solution I just found, which is 1. So I'm going to have 1 plus c is equal to 1, which means I can see when I bring my 1 over to the other side, I'm going to change it to a minus, so that 1 minus 1 gives me 0. So c in this question is actually equal to 0. So now I'm going to finish with the full formula. Therefore, Tn is equal to 2n squared. We just found that b was 1, so 1n plus 0. Or, some people choose not to write the 0, so we would have Tn is equal to 2n squared plus 1n. Both are perfectly acceptable. So take a minute here, guys, pause the video, go back, make sure to add in the 4 steps that we need to solve these type of problems, and then we're going to look at example 2. So you can see here the 4 steps again if you want to pause the video and add those in. And then I'll move the screen across so you can see the full solution again.